depends upon the resistance of these two. Does that make sense? So if this one had a big resistance, it would have a small I for the same V. So if this one had an itty bitty resistance, it's going to have a big I1. If this branch had a really big resistance, it's going to have a small I2 because they have the same V. The V's are the same in both branches. Bigger resistance, less current, smaller resistance, more current. Does that idea make sense? If it does make sense, then what is the current leaving the battery and coming back to the battery? Both, exactly. The sum of I1 plus I2. So if I1 is in this branch and I2 is in this branch, then the sum of I1 and I2 leaves the battery and comes back to the battery. The potential is going to be 12 volts no matter what. Okay. You can usually think of potential as being the thing that starts the whole process. Potential usually comes from electrochemical cells, which comes from chemistry, which comes from a chemical reaction, which is set. Potential is very, very seldom ever going to change. All right, give me a thumbs up if that makes sense. We have 5 minutes left. Okay. Any questions? All right. I promised to talk about voltmeters and ammeters. A voltmeter is something that measures potential, and because it measures potential, we measure it in parallel. In other words, we set one probe above and one probe below what we want to measure. It's kind of like if you ask me, how high is that waterfall? I'll be like, well, it starts at 200 feet and it ends at 30 feet, 170. Okay. If you don't know how high a waterfall is, look at the top and the bottom, that's how high it is. The difference between the top and the bottom. A voltmeter looks at where it starts and where it ends. Oh, by the way, is current traveling clockwise or counterclockwise in this circuit?
Well, it's positive to negative. Clockwise.
Clockwise. Yeah. Positive to negative. So if this is 8 and this is 3, then the voltmeter is going to read 5 volts. If this is 6 and this is 0, the voltmeter is going to read plus 6 volts. Get the idea? Okay. Now an ammeter measures the flow of current like a flow meter measures the flow of water. When I measured the flow of water of the San Juan River, I had to put the flow meter into the river. I couldn't just look at the water going by. It looks like about this. I had to put it in, so we do the same thing with an ammeter. You have to place an ammeter into the circuit in series. If you have some old resistors like this, modern cars don't use the blade resistors or blade fuses like this. If you have some old fuses, you can bring them in, we can burn them. You can actually see what happens when you wire your radio wrong. Okay, next, a fuse. This is an animation of a fuse being burned out. This is called a blade bus fuse. They were used in cars up until about 06, 07. Now we use itty bitty blade fuses because someone said, why does it have to be so big? And we're like, it doesn't, so we made it smaller. But older vehicles, also car stereos still use these big fat blade fuses. But a fuse is something that is rated for a certain current using a wire that is ohmic until it's not. When it gets too much current, it melts and it breaks the circuit.
So it can't overload the circuit.
Yep. If you look really close, you can see it breaking. It's like melting right there. So all it is 2 electrodes with a wire in between. That wire is calibrated for a very specific amount of current. If it exceeds that current, the wire just melts inside the little plastic container.
And then what happens when it melts? It just
It won't conduct anymore. So you place it in series with what you're trying to protect. A breaker is what you use in your house. If you're assuming your house is built after about 1940, we use breakers instead of fuses. Old houses still have these big fat fuses that screw in. But a breaker is what you use in your garage, where like clink, clink, clink. It's the big gray box with the switches. A breaker is just a spring-loaded fuse that instead of melting, it just causes the spring to engage and throws the breaker away from the circuit. Yeah.
Okay, this is a question about the voltmeter part. I thought that the electric potential was the same in the whole piece. Isn't that what volts are like? So how do you measure something that's supposed to stay the same?
I guess I'm not understanding your question. If it's 6 going out, it's say 0, 6, 0, or plus 6, 0.
So, wait, why is it 0?
Because there has to be a low potential. So this pole can't be 6. If it's 6 and 6, then you have a potential of 0.
I thought when it left was 6, it came back was 6.
It does for current. Yeah. So it's So if this thing, if this resistor right here has 6 volts going through it, 6 minus 6 is 0. So there has to be a high potential and a low potential. Okay. So tomorrow we'll talk about, or we'll do the simulation tomorrow, and then we'll work on Kirchhoff's rules after the simulation.